Hi guys, let's look at the next question. Next question is question number 4, part 1. It says M and N are midpoints of the sides QR and PQ respectively of triangle PQR. Right angle at Q, and we need to prove that PM square plus RN square is equal to 5MN square. So what this means is PN is given equal to QN, and number 2, QM is equal to MR. This is given. Next, let's look at what do they want us to prove. PM square. So let's see which triangle is this a part of. So in right triangle PQM, using Pythagoras theorem, what I get is PM square is equal to PQ square plus QM square, right? And PQ is nothing but 2 times Pn or 2 times Qn. Okay, let's see what we have on the right hand side. So we've got this one part. Let's look at the second part. So we've got Pm square already. Let's look at Rn square. So Rn is a part of the right triangle QNR. So point number 5, in a right triangle QNR, using Pythagoras theorem, what we get is Rn square is equal to Qn square plus Qr square. Yes, Qn square plus Qr square. So we've got Rn square as well. Let's add. So add 4 and 6, and we get Pm square plus Rn square is equal to Pq square plus Qm square plus Qn square plus Qr square. We've just added these elements. Pq square and Qm square comes from equation 4, and Qn square plus Qr square comes from equation 6. Let's see if we can get something together. Pq can be written as 2 times Qn. Yes, so Pq can be written as 2 times Qn whole square plus Qm is Qm square, Qn is Qn square, and Qr can be written as 2 times Qm whole square. The reason this is 0.8 Pm square plus Rn square. The reason, since Pq is equal to 2 times Qn and Qr is equal to 2 times Qm. So my right hand side becomes 4Qn square plus Qm square plus Qn square plus 4Qm square. Let's take Qn square together and Qm square together. So left hand side remains the same, Pm square plus Rn square. So this is 5 times Qn square plus 5 times Qm square. Let's take 5 common. So this is Qn square plus Qm square. So left hand side is Pm square plus Rn square. I think we've almost reached the answer. Let's see what can be done. So this means Pm square plus Rn square is equal to 5 times Qn plus Qm whole square is equal to Mn square, since in a right triangle QNM, Mn square not M square, Mn square is equal to Qn square plus Qm square. So this is, instead of Qm square plus Qn square, we've written Mn square. So therefore LHS is equal to RHS, hence proved. Done. So we've solved this question. This is one way of solving this question. I will look at another way of solving this question in a few more minutes. So let's look at the next part of the question. The next part of the question is part 2, where we need to prove that 4Pm square is equal to 4PQ square plus QR square. So let's look at what is on my left hand side. So it's Pm square, which means I'm looking at the triangle PQM. So Let's look at fresh points. So this is in a right triangle PQM using Pythagoras theorem. What I get is PM square is equal to PQ square plus QM square. Now my left hand side, they want 4PM square. So let's just multiply both sides by 4, which means if I multiply both sides by 4, I get 4PM square is equal to 4PQ square plus 4QM square. Now I have got 4PQ square already. I have got 4PM square already. I just need to convert 4QM square into QR square. Let's see if we can do something about it. So equation number 4, moving from the same one, which is 4PM square is equal to 4PQ square plus QM, which is this, is half of QR. They want QR, so the relation between QM and QR is that QM is half of QR, which means 4 times QM, in this case half of QR whole square. Reason, since QM is equal to half of QR. So this is, the right hand side is 4PQ square plus 4 multiplied with 1 by 4 QR square. This gets cancelled. So my right hand side is 4PQ square plus QR square. And my left hand side remains 4PM square. So that's exactly what they wanted us to prove. Therefore, hence proved. Let's just check if we've got this right. 4PM square is equal to 4PQ square plus QR square. Please note I started with the left hand side. I substituted the values. I noticed they had a 4 here in front of PM square. That's the reason I multiplied it with 4. And I realized that I've got 2 values in the what they want me to prove. So I figured out the relation between QM square and the number that, and the value that they wanted between QM and QR. Let's look at the next question. The next question that we do is part 3 of this, which is 4Rn square is equal to PQ square plus 4QR square. Again, let's look at the left hand side. So Rn square, which means I am looking at the right triangle QNR. So let's work with this. So this is in right triangle QNR using Pythagoras theorem. What I get is Rn square is equal to Qn square plus QR square. Q1 square plus QR square. Perfect. They want 4 times Rn square, which means let's multiply both sides by 4, which means I get 4Rn square is equal to 4Qn square plus 4QR square. Now let's check what we've got. So I've got 4Rn square already on my left hand side. They want 4QR square. I've got 4QR square as well, which means all I need to do is convert 4Qn square into PQ square. Let's see if there is any relationship between Qn and PQ. Qn is half of PQ. Exactly the same question as last time. Last time we had QM is equal to half of QR. This time we are getting Qn is equal to half of PQ. So the left hand side remains 4Rn square, and instead of Qn I write half of PQ whole square plus 4QR square. Reason, since Qn is equal to half of PQ. This becomes 4 multiplied with 1 upon 4 PQ square plus 4 QR square. 4 and 4 gets cancelled. The left hand side is still 4Rn square, and we have 4Rn square is equal to PQ square plus 4QR square. Done. That's the what they wanted us to prove. So hence proved. Let's look at the next part of this question. The next part of this question is part 4, where we need to add 4 times Pm square plus 4 times Rn square is equal to 5 Pr square. Now for this we will have to go back to what we proved in part 2 and part 3. So in part 2 I will just write what we've already proved. Part 2 we proved that 4 Pm square is equal to 4 Pq square plus Qr square. We've already proved this. Part 3 we have proved 4 Rn square is equal to Pq square plus 4 Qr square. So let's see what do they want us to prove in part 4. They want us to add 4 Pm square and 4 Rn square, which means let's add these two. So adding 2 and 3, which we've already proved. Let's add this. So what I get is 4 Pm square plus 4 Rn square. So this is my left hand side. Let's get what's on the right hand side. So on the right hand side I get 4 Pq square plus Qr square plus Pq square plus 4 Qr square. Let's combine Pq together, so I get 5 Pq square, and let's take Qr together, so I get 5 Qr square. Common element 5, which means 5 times Pq square plus Qr square. The left hand side is 4 times Pm square plus Rn square. 5 times Pq square plus Qr square. So if I look at the big triangle PQR, Pq square plus Qr square is equal to Pr square. So 5 Pr square, since in a right triangle PQR, using Pythagoras theorem, we get Pr square is equal to Pq square plus Qr square. So that's the reason for this, which means we've got what the question wanted us to prove, which is 4 times Pm square plus Rn square is equal to 5 Pr square. So this is one method that is used to solve this question. In the next video, I will discuss a method which uses algebra to solve the same questions. So do watch the next video. Thank you so much. Take care. Be safe. I'll see you with the next video. Bye bye.